Now what we're going to do is we're going to evaluate expressions with fractional exponents. So let's say we're starting with example 4. And we have 27 to the 2/3. So 27 to the 2/3 is going to be equal to the cube root of 27 squared. And the cube root of 27 is what times itself equals 27. And you could probably do it in the calculator. If you're not sure, it's there's a cube root thing often, 27, which is 3. And that's going to give us 3 squared, which is going to be equal to 9. So 27 to the 2/3 is equal to 9. Another way we could have done it, here, we'll call it 4 again, kind of 4 alternative ways of doing it. So another way of doing 27 to the 2/3 would have been, we could have said, okay, that's 27 squared to the cube root. I'm going to need a calculator for this one. 27 squared is 729, which is going to be the cube root of 729, which is, if you plug it in, which is also 9. I'm going to pause slightly here. So say with the calculator, if I wanted to type in the third root of, say, 8, and I don't want to use that special button, depending on your calculator, there might be a different button you could use. It may look like something like this, or it may look like this, or usually one of those two. On the calculator I have here, it's going to be this button over there. So you type in the root, you type in, so that I'm describing the type of root it's going to be. It's going to be the third root of 8, and it's going to be 2. If I want to know what the 9th root of 512 was, I would type in the 9th root of 512, also 2. Well, clearly not as original as I might think. Okay, back to our regularly scheduled program. So what we have is example 5, 8 to the power of 5/3. So that's going to be equal to, I'm going to do the root first if I can because it's easier. The cube root of 8 is 2, and 2 to the 5 is 32. Let's say I had negative 8 to the 5/3. So negative 8 to the 5/3 is going to be the cube root of negative 8 to the 5. And you may be tempted at this point to say, ooh, we've got a problem. But as you may or may not recall from a previous lesson, the cube root of a negative number is still possible because negative 2 times negative 2 times negative 2 is in fact negative 8. So this becomes negative 2 to the 5, which is minus 32. Let's continue with 8 to the 5/3. Let's do the different permutations of it. So let's say we have 8 to the negative 5/3. So that's going to be equal to 1 over 8 to the positive 5/3, which is going to be equal to 1 over the cube root of 8 to the 5, which we all know now is 1 over 2 to the 5, which is 1 over 32. So notice, 8 to the 5 over 3 is 32. Negative 8 to the 5 over 3 is negative 32. 8 to the negative 5 over 3 is 1 over, it's a fraction, 1 over 32. Should we do, just for completeness sake, that's going to be the same thing as 1 over negative 8 to the positive 5 over 3. So the exponent changes, but not the base, which becomes 1 over the cube root of negative 8 to the 5, which is 1 over negative 2 to the 5, which is 1 over negative 32. Now I've been saying fractions, but really, there's nothing stopping it from being a decimal either. It's an irrational decimal would be a problem, but we're not going to deal with that. But a rational decimal, we could always write, if you have a rational decimal, 0.75, what you could do is you could write that as a fraction. So 16 to the 0.75 is 16 to the 3 over 4, which is the 4th root of 16 cubed, which is 2 to the 3, which is 8. And we could do 1024 to the power of negative 0.1, and that would be equal to, so negative 0.1 is the same thing as 1024 to the negative 1 over 10, which is 1 over 1024 to the power of positive 1 over 10. That's what the negative exponent does, which is 1 over the 10th root of 1024, which is 1/2. So 1024 to the negative 0.1 is equal to 1/2, or 0.5.